Alright, here's your riddle. How much mud, measured in liters, is there in a rectangular hole 2 meters wide, 3 meters long, and 3 meters deep? Alright, there you go. The answer is none. It's a hole. There's no mud in the hole. Alright. I don't know if you got that or not. Let me know if you got that. Okay, anyway, a couple more terms. We're going to talk about position vector in the first part. We're going to talk about the magnitude of a vector in the next part. How do we find that? And the first thing I want you to understand here is that we could say, well, we want to find, let's say, a vector PQ. Okay, we want to find vector PQ. And what would vector PQ be equal to? Well, if you have to understand, number one, that P is where you start. That's where the tail is. That's the starting point. So you could do this if you see the vector. I mean, if you see the 2 points in, if you plot the points, you could easily do this by just counting over 1, 2, 3, 4, 5, and up 1, 2. Okay, so we can see that the vector PQ would be the vector 5, 2. Remember, it's just for the starting point, and then you go over to the right, x component or horizontal component, and then you go up or down, whichever. And this is where this is the tip. This is where you finish. Okay, that's where the vector ends. Okay, so 5, 2, we could do that. Well, what would QP be equal to? Well, Q is where it starts. Okay, and so I want you to try that one on your own. QP is where Q is where it starts, P is where it ends, and so QP, again, pause the video. I'm going to just go ahead and do the answer right now. 1, 2, 3, 4, 5, and down 1, 2. So -5, because it's 5 units to the left, and then down 2, so we write -2. Well, do you always have to sit there and count, or is there a better way? Well, let's do this. PQ would be equal to, if you notice here, where you end, you take the horizontal component 9 and you subtract the horizontal component from P. So the horizontal component from where you end, 9, minus the horizontal component from where you started, 4. 5 minus 3 would be the vertical component, and you can see we get the same answer we did above, 5, 2. And QP, same kind of thing, where we end at P, start at Q, so we take the horizontal component from P, 4 minus 9, and then we do the vertical component from P first, 3 minus 5. 3 minus 5 gives us the -5, -2, just like we got up here. Okay, so I want you to not, I mean, the book has a good kind of a, I mean, it's got a formula for it, and it's got a bunch of letters in it and everything, but I have, over the years, I've noticed that students that try to memorize formulas without meaning, they don't really understand the formula, and then they forget. If you forget one thing, then you're toast. So try not to memorize the formula, understand the concept behind it, where if you just want to find a position vector, that's what these are called. These are position vectors that indicate if you were to put the initial point at the origin, well, where would the end of it be? Well, over 5 and up 2, down 5 and down 2, or left 5 and down 2 for the QP. Okay, so I'm going to have you try one on your own. Find the position vector. Let's see if you got it. Okay, I'll leave that right there. Find the position vector V, which would be equal to the vector P1 to P2. Okay, pause the video, try it on your own, and I'm going to do that. V equaling P1 to P2. We're ending at P2, so we're going to take the horizontal component from P2, and we're going to subtract the horizontal component from P1, and then we're doing the same for the vertical component, 6 minus 2. So we get 4 minus -1 is 5, and 6 minus 2 is 4. So the position vector P1, P2 is 5, 4, and that's your answer. Okay, that's the position vector. Okay, and let's go ahead and move all the way to magnitude of a vector. This should be our last concept unless I missed something. And so let me get my paper ready. Magnitude of a vector. And magnitude of a vector, we're going to use special notation to represent the length of a vector. And that's what the magnitude is. It's the length. Put that in here, length, okay, of a vector. And let's take, for example, we have vector v, which we're going to give it a comma b as the name of our vector component form. We could also use just to review the unit vector form, ai plus bj, and so we have all three forms. Now, what's the length of a vector? The length of a vector, magnitude of vector v, we use these double lines. Okay, so when you see the double lines, that's what magnitude means. Okay, and so how do we do that? Well, again, I don't like to just give you the formula. I want you to understand the basis behind the formula, and it's a really easy one when you understand, if you can remember that theorem, you know, a squared plus b squared equals c squared, you know that one? So if we have a units here, okay, there's a units there, and we go b units here, okay, now what's the length of the vector? Well, there's the vector right there. You go over a and up b, so that's vector ab. What's the length? So let's call that vector v, okay, and there's vector v. So what's the length of the vector? You should be able to do that right now. That's the Pythagorean theorem, right? It's the square root of a squared plus b squared. That's all. That's all you have to do. That's the length of the vector. Okay? I don't know. Were you expecting more? Let's try one. I don't know. I'm feeling kind of goofy right now. Let's let W. Let's use a different letter finally. W equals -1 comma. No, let's not do that. -4 comma 3. Okay. Let's make it the easiest that we can make it. All right. And so let's put that on this same grid here. If we're going to find the length of the vector, so -4, 1, 2, 3, 4, comma 3, 1, 2, 3, and so we're going to draw this vector. -4 comma 3 goes right there. Okay, so there's vector W. Okay, so there's 4 there, and there's 3 there. So the magnitude then of vector W, when you plot it, it makes it really easy, because then you're just finding the hypotenuse of that right triangle. So you get -4 squared, so the square of the horizontal component plus the square of the vertical component, and you know that's 16 plus 9, 25. Radical 25 is 5. And so we have the length of the vector. Okay. Okay, well, I don't know how much harder I can make that. I don't think I can, but one of my favorite problems is what we will end with. Okay, and again, I think this is the last thing. We're going to end with find a unit vector, okay, in the same direction as a given vector. And the given vector, let's u, v, w, x. Let's call it v, as v equaling 2, 5. Okay, so we have this vector 2, 5, and we're going to try to find a unit vector that is in the same direction. Now you can memorize the formula or you can memorize the concept. Okay, I love concepts. I mean, formulas are good, but you know, they're a little bit limited. You understand concepts, you don't have to memorize as much stuff. So let's plot 2, 5. Okay, over 2 and up 1, 2, 3, 4, 5. I'm going to put it right there. Where's my straight edge? Stuff is everywhere now. There we go. Okay, so we're going to draw the vector 2, 5. All right, so this is my favorite problem because this is the one that challenges students the most. So we're going to find a unit vector going in the same direction as the vector that we have here. So this is vector v, which we know is 2, 5. Okay, well, let's do this. Let's find the magnitude of vector v. Why do we want to do that? Well, let's check to see if it's 1, first of all. Well, it's not. We can see it's not 1. 2 squared plus 5 squared, and we get radical 4 plus 25, so radical 29. That vector has length 29. Okay, so vector v has a length of radical, did I say 29? Radical 29. Okay. Well, guess what? If we want to find a vector that is one unit going that same direction, okay, there's this thing called similar triangles that you learned way back in geometry. Well, that's 2 and that's 5. Okay, that over 2 and up 5. What we want is we want the hypotenuse of this little tiny triangle. I don't know if you can see this or not. We got a little tiny triangle in here. We want the hypotenuse to be 1, but we want it to be going in the same direction. So guess what we have to do? We take each component and we divide each of these components of the original vector by the length of the vector. And so we have 2 over radical 29. So anyway, the unit vector, we do this. So the unit vector, this is what we're looking for, would be in the same direction. Same direction. Can you see that? Yeah. Same direction as the vector 2, 5. Okay, that's what we're looking for. Would be the vector 2, 5 divided by, or we divide each component by the length of the vector. Okay, well, you're going to have to think about that. You have to look at that a little bit more. And so we get, remember the scalar multiplied by a vector, we get 2 over radical 29. I don't care if you rationalize the denominator. And we get 5 over radical 29. Well, why does that work? Well, I challenge you. I challenge you to find the length of this vector. This is our answer, by the way. You just take each component, you find the length of the original vector, and divide each component by that length. That's it. Well, why does that work? We wanted a unit vector. Now, unit vector means what? That means that our vector has length 1. So let's try to find the length of this vector. If we take the square root of 2 over radical 29 squared, oh shoot, I did 92, I'm dyslexic right now, squared, plus 5 over radical 29 squared, what do we get? Okay, let's see if we can do a lot of this in our head. We get 4 over 29, radical, 4 over 29. I hope this works. And then you get plus 25 over 29 under the radical, and we get radical 29 over 29. We get 1. So we got a vector of length 1, and because similar triangles, we know that we can divide each of these original components by one number and get a similar triangle, meaning that the hypotenuse of these triangles are going to go in the same exact direction. And that's it. So you can memorize just, if you want to find a unit vector in the same direction, you can just say, all right, I'm going to find the length of the vector and divide each component by that and be done with it without any meaning. But if you forget part of that, then you're toast. But if you understand the meaning behind it and the reason why, it really builds your self-esteem because you really have a lot more knowledge and your brain works better and all those good things. So I'd like to say it's late at night. That's why I'm getting a little bit goofy, but it's not. It's 4:25 on Sunday afternoon, but I know that I'm at the end. I believe I'm at the end. I might have another one, but I believe I'm at the end. I get to go spend time with my family. Hope you guys are having a great night, and I will see you soon.